Hi everyone, welcome back to my channel. It's Demetrius here from OB Pixel and once again from the OBI Academy brand. Thank you for joining today. I will be taking you into the world of artificial intelligence and building AI models. And as an instructor, and I've been an instructor since 1989, yes, a long time, I've learned over time that the most important thing when it comes to content and explaining the content to students is to be able to break down that content down to understandable chunks of information. And this is one of the hardest things to do. As all instructors will tell you, it's very easy for us to learn something. Yes, it takes a long time. And it took me the better part of 6 years to truly understand artificial intelligence and machine learning. But I dove into the industry because I wanted to progress my IT career because I've been an information technology specialist and expert for the last 37 years. And I run a consultancy firm that does penetration testing, digital forensics, red team attacking, all that kind of stuff for companies and organizations and people in companies. And I also deliver training for companies as well on these topics. And artificial intelligence is a brand new subject for many people, and it was for me in the beginning. So I dove into it, and the objective was to try and understand the concepts in the way that I would have liked to have learned them as a student. So what I've decided to do is take down information about, okay, how do we build an AI model? And then break it down into really 7 simple steps. I say simple, but these are the steps that you can use as a framework for building your AI models. And I decided, that's not enough. As an instructor, we want to always provide analogy and context as to, how to do something, where it's used in the real world, and for example, how does it affect a particular system or an application or usage in a company? How does it give a company return on investment? That kind of thing. So today, I will break down a presentation I've put down for you. You are able to download this presentation anytime you want for free. It'll be available in the description. I don't request any email addresses and names and surnames. I don't need that. You may download it for free anytime you want. This is available for you anytime. And it's really a small subset of the courses that I've built on OBI Academy. So if you following this video, if you're interested in finding more information about the courses, please visit OBI Academy online and take a look at what course will suit you best. But for now, stay tuned and we'll talk about the 7 simple steps of building an AI model around spam filters in IT technology. Okay, so welcome back. So let's dive into this. I'm going to take you into the presentation system now. All right, so I have this presentation available to you. So we're going to build an AI model in 7 steps. And really, it's a very daunting task for a lot of people when they get into artificial intelligence. They really are concerned about, okay, how they're going to go ahead and build these steps out. So we need to first think about, okay, we're going to define the problem to deploy the model basically. And then you're going to create an AI solution around, the needs that you have so that the AI can tailor the right things for you. So let's build, example, a model that predicts whether an email is spam or if it's not spam, because you must always do the condition as well. So this is essentially a classification problem where 2 classes exist, spam or not spam. Okay, so let's dig in. So the first thing is you're going to define your problem. So for example, you want to build a model that predicts whether an email is spam or not. So again, this is classification, right? So the first thing you do is you understand the goal. So the goal is you clearly define what problem you want the AI to solve, in this case spam. Are you looking to classify emails as spam? Do you want to predict consumer behavior? You need to be specific with AI. AI needs specific details. Then you need to label the data. So for classification problems, you have to determine how you will label your data into very distinct categories that the model can learn from. Remember, AI is not as intelligent as a human. It just can process a lot faster than humans right now. So we need to classify and break down the details for the AI so it knows how to deal with the understanding of what we're asking it and the prediction model. And then, of course, we then, in stage 3 of this first stage is, or the step 3 in the first stage is to identify the inputs coming into the system. So what data will you feed into this model? All right, the text, the images, the numerical information. And this informs essentially the data collection and the processing part of the AI model. So the second stage is going to be a very important stage for you, and that is to collect and prepare the data. So, for example, for the spam filter, you might want to use a data set like the Enron data set, which basically contains labeled emails as spam or not spam. So you'll pre-process the data by removing the irrelevant information, like email headers that we don't really need, and then convert all the text to lowercase, because AI doesn't really give a damn about uppercase and lowercase, it just cares about the text. And then perhaps use a technique like TF-IDF, which is term frequency inverse document frequency, to convert text into, say, a numerical format that the model can understand. And we'll explain TF-IDF next after this little screen. So first we find the suitable data sets, and then researching existing data sets relevant to your problem is important. So, for example, for a spam filter, you might want to use the Enron database, like I said. And if you want to use that data set, that hyperlink is available to you on the screen, and you can just click that link and go and download the data set. However, if no data set exists, you can collect your own data through the different methods like web scraping or surveys or your content on your site. After that, within the stage 2, you need to pre-process the data. In other words, we've got to clean and structure the raw data to be model ready, so you don't have any repetitive information. It's clean information, it's accurate information. So this includes removing irrelevant parts, handling missing data, converting data into numerical formats so that the computer systems and the AI models can understand, because they don't understand anything except numbers. And then techniques like the TF-IDF are often used for text data to extract meaningful features out of that data. So let's take a little bit of a deeper dive into this concept of TF-IDF. What, first of all, is the Enron database, and then what is TF-IDF? So the Enron email dataset, let me give you an analogy. Consider a chef preparing ingredients for a recipe. The chef must clean, chop, and sometimes marinate the ingredients before cooking. Similarly, pre-processing the Enron dataset involves cleaning the data, removing the useless parts, organizing it, in other words, structuring for analysis, and then preparing it, like converting text into numbers so that it's ready for the model to cook or analyze. In context, for our spam filter in this case, the Enron dataset, once pre-processed, becomes a clean and structured set of emails labeled as spam or not spam, which the model can then learn from and do accurate predictions later on. And to do this, it'll use, say, for example, TF-IDF, which is term frequency or inverse document frequency. And essentially, let me give you a bit of an analogy on how this thing works. So think of a library with thousands of books. Some words like the word the or is appears in almost all the books, so they're not very helpful in finding a specific topic. They just assist. But there's also a lot of repetition, I should say, of these words. But words like philosophy, all right, they might only appear in the books about very specific subjects. So those are very important words. So TF-IDF measures how important a word is within a document relative to all the documents in the datasets. It's like finding those unique words that help you quickly identify what book is about in a giant, massive library. Imagine the Congress Library, the Library of Congress in the United States. I mean, it's got over 20 million books. Can you imagine trying to find a particular topic if you don't have any understanding of classification and you don't actually use term frequency, inverse, and document frequency, so that we can very specifically go to that particular type of book we're looking for because it's talking about philosophy. Okay? You try to find philosophy books inside a Library of Congress without knowing exactly, what's on the cover, what words are available, what's been put into the system. Without that kind of filtering process, it makes it very difficult. So TF-IDF is very important. And for example, in context of what we're doing here, the spam filter, TF-IDF helps the model understand which words are important in distinguishing spam or non-spam emails by sort of giving a higher weight to words that are unique, usually to spam, and then those that are unique to non-spam emails. So it gives it a bit of a weight system and a frequency so that it knows, okay, well, these words are typically used in spam and these words are typically not used in spam. So it does that weighting system. Is it 100% accurate? No, it can't be. There is no such thing as 100% accuracy because spam emails change all the time. Hackers are constantly modifying the way they do spam email, but it's very precise in accordance to what it can do compared to, say, normal spam filtering in email servers. Using artificial intelligence with TF-IDF enhances spam filters considerably. And believe me, I'm in the IT information security sector, and I know how well this works. Now, the third stage in building your model is really to choose that data and to train the model. So for the spam classification, a good starting point essentially is something like the naive Bayes classifier, which we'll explain a bit further down the line, which is very simple. It's a simple and effective way for text classification and tasks. So using, say, the pre-processed Enron dataset, you'll train the naive Bayes classifier by providing it with the text of the emails as an input and whether each email is spam or not as the output. So, number one, you'll select your algorithm in the stage 3. So based on the problem type, you choose an appropriate machine learning algorithm, and in this case, the naive Bayes classifier for text classification, or essentially neural networks, for example, in image recognition. Okay? Then the second part of that would be to split the data out. So you'll divide the data set into training and testing data sets. Then the model learns from the training data. So while you're training the model, you're going to feed training data into the algorithm, allowing it to continuously adjust its parameters to better fit the data. Okay? To understand this a little bit further, let's break down how this naive Bayes classifier actually works. And I'll give you an analogy and some context, because it's very complicated, but I'm breaking it down in an easy way to understand. So imagine you trying to decide to take an umbrella when you leave the house. Because I live in the UK and I live in Wales, because it's always raining, constantly raining. So you look out the window, and if you see dark clouds, which happens a lot, a piece of evidence, you think, it might be rain, the category. So the naive Bayes classifier works similarly to this. It makes predictions, like if an email is spam or not, based on the evidence it sees in the data, in other words, in the email text, assuming each piece of evidence, like the words in the email, is independent of the others. So in context, in the spam filter, the naive Bayes classifier uses the words in emails to independently contribute to the probability of an email being spam or not, making it quite a straightforward and effective choice in this case for classification of emails. It's a very cool system to use. It's a very nice process. And in my courses, the CIMLP and the GPTP courses, I really dig really deep into the naive Bayes classifier and give you many examples, even with Python code, on how to do this. Now, moving on, stage 4, the fourth step, this is where we have in a way the analysis part. So we evaluate the model performance. So for example, after training, evaluating the model's performance using sort of separate test data and the actual data, then we can look at the test of those emails and metrics like accuracy, in other words, the percentage of emails that are correctly classified, and then precision, the percentage of emails classified as spam that were actually spam, because you need to have true positives here. And for example, and when they're commonly used, basically. So we are going to test the model, run the trained model on the test data set, and see how well it performs on the unseen data. And then calculate metrics. Calculate the metrics, like depending on the problem you have, use sort of the relevant evaluation metrics like accuracy, precision, recall, F1 score to measure the model's performance. And I'm going to break those down and give you an analogy of those in the next slide. And then, of course, once we do that, the final step to step 4 is to analyze the results and examine sort of which types of data the model struggles with, because it's going to struggle. I mean, it's AI, it's not perfection, and looks for areas of improvement. So those are the stages of the evaluation of the model and how it's performing. Now, let's take a look at the way we calculate these metrics, because this gets a little bit complex, but don't worry, I've broken it down in an easy way for you to understand. So let me give you an analogy of catching a fish in a pond. Imagine you fishing in a pond where you want, say, to catch many redfish, spam emails. Many redfish as possible. Okay, so these are the spam emails, which, assuming you're going to be avoiding the bluefish, which is actually the legitimate emails, let's say in this analogy. So precision is, for example, your ability to ensure almost every fish you catch is red. So how precise are you in catching a spam email? If you catch many blue fish while you're trying to get red ones, your precision is obviously low, and vice versa. In terms of recall, this is about catching all the red fish in the pond. So if you leave many red fish in the pond, in other words, the missed spam, your recall is low. So it's kind of like an inverse of, say, precision. Those two work together. And then what you have to tie the two up is what we call the F1 score. There's a little formula on the screen there, which is F1 is equal to 2 times the precision multiplied by the recall divided by the precision plus the recall. And essentially, really, this is, in simple terms, it's like measuring your success in fishing by considering both how many of the right fish you catch, in other words, that's your precision, the red fish, the spam emails, and how many of the total available red fish, the spam email, you've managed to get out of the pond. Essentially, that's recall. So you want to maximize the catching of the red fish, the spam email, while minimizing the blue fish in your catch. So you trying to get precise in how many red fish you can catch, which is the spam emails, but you also want to figure out how many of those you have caught in accordance to how many spam emails have come in total in your system, and that's your the recall side. So you're working on a decent average, and that's what the F1 score is all about. So in context of our spam filter, let's break this down a bit further. So essentially, precision is the spam filter that basically, the filter context means that it's percentage of emails the filter labels as spam versus non-spam emails, and then recall is the percentage of the actual spam emails that the filter successfully identifies in the entire pool of email that's coming in. And again, the F1 score becomes the important metric because it tells you how well your spam filter is performing. And it's not just, hopefully just only catching spam emails, the high recall, but also it also makes sure that good emails are not incorrectly marked as spam. So that's what we call high precision, because we don't want to have any false positives. We want to have true positives, okay? Not false positives. So in building a spam filter, we are aiming for a high F1 score, meaning you're efficiently identifying email that is spam without sacrificing the accuracy of your filter by wrongly classifying good emails as spam. It's about finding the perfect balance, really, between, being cautious and being aggressive in spam detection, because being overly cautious works against you, and being overly aggressive works against you. So you need a good balance between the two, and that's what F-score does by combining precision and recall together, giving you the ability to deal with evaluating model performance and calculating the metrics correctly. So the stage 5, or the fifth step, is really optimizing and fine-tuning. So for example, if this model's precision is low, you might want to fine-tune it by adjusting its parameters, like the threshold for classifying an email as spam. Or you could try a different algorithm like support vector machines to see if it performs better. And I'll break down SVMs next. So we adjust the hyperparameters, fine-tune the model settings like learning rates, regularization, essentially to improve how general the ability is. We work on feature engineering, so we experiment with different ways to represent your data features to boost the model's signal. And then we try the different algorithms. Hopefully, if performance is great, then we don't have to worry. But if it's poor, you test an alternative algorithm like SVM instead of the Naive-Bayes classifier. So you're training for decathlon. It's really an athletic event consisting of 10 different track and field events and disciplines, right? It's a pretty huge feat for an athlete to do. If you train too much on just one of the events, which can happen, like the 100-meter sprint, at the expense of the others, because you're not specializing, now you're being generalist when it comes to decathlons, you might perform exceptionally well in that single event, but very poorly in the overall decathlon as a whole. So regularization in machine learning is like balanced training for athletes that do decathlons. It prevents you from focusing too much on small parts of the data, in other words, overfitting, and instead encourages you to train for every event, in other words, evenly across all the events. Basically, this is what we call the features of the data, to perform well overall, which is generally a better way of doing things. So in context of, let's say, for example, back to our spam filter, in the spam filter model, regularization works by penalizing the model for being too complex, which means relying too heavily on any single or small group of features to make a decision. So You don't want to have that. So this is how it applies. Without regularization, your spam filter might get really good at detecting spam based on peculiarities, anomalies of the training data, like the overemphasizing of words like free and winner. This is like overtraining for the 100-meter sprint because you're being too specific, okay? But these peculiarities might not generalize well to all spam. So especially like spammers change their tactics all the time, depending on the seasons and what's happening and what's currently running in industry and so on. So in unseen data, the real world emails, the filter might perform poorly, right? Misclassification of spam will occur, and non-spam and vice versa will be problematic for you. So you need regularization because it's what we call the L1 and L2 model. Essentially, the model is discouraged from putting too much weight on these specific features. Instead, it's encouraged to consider a broader set of characteristics, making it a bit more robust, obviously, and a better solution in terms of identifying spam across varied instances and situations, not just those similar to the training data sets that you have. Because you can't just rely on your data sets that you have. You need to expand further than your data set, because your data set is one thing, but it's going to have issues, it's going to have inaccuracies, and it's not going to be complete. So you need to expand that, and using regularization will help. So in essence, it helps you ensure that the spam filter is not just tuned to the specifics of the training data, but it is adaptable, okay? And it is effective in identifying spam in a wide array of real-world conditions. So it improves its ability over time to essentially generalize from the training data to the actual task of, say, filtering in diverse email environments, and really broadens out the scope of how it works. That's pretty cool. And because of regularization and how it's been used, we can then proceed with using the different algorithm for dealing with this. And support vector machines, let me give you an analogy for this. Imagine you're separating apples and oranges on a table. They are different things. They're still fruits though. But you want to draw a line that clearly demarcates or divides the apples from the oranges. SVM finds the best line, or what we call a hyperplane, in higher dimensions that separates the different categories with the widest margin, ensuring a clear distinction between apples and oranges. So in context, in the spam filter scenario that we have, SVM helps to distinctly separate spam emails from non-spam emails, ensuring that the model makes accurate classifications, even if the decision is not entirely straightforward or easy to make. So in combination of SVMs and regularization, it is a lot easier to optimize and fine-tune if the naive Bayes classifier is not working well for you in terms of the modeling. Okay? Now, let's move on to stage 6. And in step 6, for example, we have deploying the model. This is where you're going to get to see if everything's working well. So once the model performs well, while you've tested it, you now can deploy it into an email system with it. Basically, it's going to automatically classify incoming emails as spam or not spam, and then it sorts them into the appropriate sort of folders. Currently, a lot of the systems that we have when it comes to spam filtering and cleaning out email is actually using AI like this. You just don't often see this. So in terms of deploying the model, you're going to have 3 stages here. You're going to have integration. So this is where you build a system to integrate your model with the relevant applications or workflows that you have in your company. And then you have the scalability side of things. Okay, and scalability is important because this is where you ensure your deployed model can handle increased amounts of live data and traffic, right? This is where your model really shines, if you can handle scalability, because that's the idea of having AI, right? Is to handle the vast amounts of data coming in and have our spam filter working accurately according to all that data, not just the training data set that we used. And then in terms of monitoring, you're going to implement tracking to monitor the model's real world performance based on all the training data sets that you have, so you can create some form of pattern, and then that will hopefully catch the errors that come through. Okay. Now, with number 7, the last stage, step 7, it's all about maintaining the model, and essentially this is a periodic monitoring and updating process. So over time, spammers might change their tactics, and it's not just might, they do. And the model might start misclassifying email, and you're going to have false positives and things coming in that say that they're spam email, but well, you're catching spam email, but it's not spam email. You might also get what we call true negatives, which means it just doesn't work at all as a model, so it's failing altogether because it's definitely a spam email, but it didn't catch it as spam, so you've got a real problem there. You've gone past the stage of being a true positive. So you'll need to continuously monitor the model's performance and periodically retain the training data set and constantly update it with every changes that you make when it comes to deployment. And you'll have to retrain the model with the new data to ensure it remains effective over and over and over again. So this process is very important, right? The monitoring and updating of your data sets based on the testing, implementation, and maintaining the model. This is quite important, and it's a periodic pre-training process. So when you periodically retrain, you retraining your model regularly with fresh data to adapt to changes over time and handle how spam is constantly being modified and changed by the hackers of the world, or the malicious threat actors that are spending their vast amount of hours sending out phishing emails and spam emails. You'll also be continuously improving by identifying any enhancements that you need to make to the model through any new data sources and any algorithms that you may be changing along the way. And then you'll also finally, once you've got a decent baseline, you will adapt that baseline and improve the security of the company when it comes to spam filtering, and you'll redefine the goals again. So as the needs evolve, you'll reevaluate and refine the problem scope for your model, and then you'll go back once again to the beginning stages of retraining the models and starting again and running through all 7 steps again to basically deal with your model that is dealing with spam filtering. I wanted to take you down this little road of building a model in 7 really easy steps and giving you a little bit of insight as to what is involved in that. I didn't want to take you too far into the explanations, but just to give you a little bit of insight as to what is involved, and if you want to dig in a bit further and take, for example, these stages in terms of building an AI model, defining your problem, collecting and preparing data, dealing with different types of data sets, right? Dealing with specific kind of techniques and algorithms in terms of the way things are predicted and dealt with inside the system, and how it predicts certain words and so on, with things like TF-IDF, choosing and training a model, selecting the right data, selecting the right algorithms, using things like naive Bayes, classifiers, and regularization, for example. Selecting the algorithm, splitting out the data, training the model, digging deep into how these particular algorithms work, then evaluating the performance of the models and really testing the model with test data, calculating metrics, doing analysis, and when you're calculating, using techniques that really help with regards to things like precision and recall. Precision being, where you very specific to one particular thing you're looking for, and recalling is when you're looking at an average of everything being picked up, and then dealing with that effectively, for example, spam filters. And then of course the optimization and fine-tuning, which is potentially a stage where you may alter the algorithms that you're using. You may have to adjust parameters and add additional features and then try those different algorithms. So in this case, we were talking about SVMs and regularization. So regularization will help you deal with the concentration across the board of all the emails coming across into your systems, rather than concentrating on one type of thing you're looking for. And then ultimately the support vector machines, which will give you better classification while you're doing that. And then once you separating out all those classifications, gives the AI model a bit of just the best chance it can possibly have to allow you to be allow it to be an effective model, and give you the ability to then deploy the model, integrate it into your organization, deal with the scalability of it, and then have the beginning stages of the monitoring and ensuring that the particular model is actually working for you. And then hopefully that leads to maintaining the model. So if you want to dig a bit further, these details are available on my courses on OBI Academy. The details are on the screen, and they specifically outlined in two of my courses, the CIMLP, which is the Certified Artificial Intelligence and Machine Learning Professional course, and the GPTP2 course, which is the Generative Python Text Prompting course, version 2, where I dig into these types of concepts, algorithms, techniques, solutions, and we go much further into the details and work with labs and exercises and Python programming behind it, and how you truly go ahead and build these models themselves. So hopefully today I've given you a little bit of insight. Thank you for your time. If you like these kind of videos, please let me know. Also, hit the like, subscribe, and hit the notification bell so that you can get the latest videos that I release. Thank you for supporting me in my channel. I'm trying to build this channel and provide content for you for free, and give you the best head start when it comes to getting into artificial intelligence and machine learning and Python programming and blockchain technologies and so many other information security type of solutions and sectors that you're interested in. My name's Demetrius, once again from OBI Pixel and OBI Academy today. Thank you for listening, and I'm signing out.